Okay, number 3, no calculator from here out. What'd you guys think of this problem? Um, hopefully, hopefully not too bad. Um, all right, function is defined here. Graph is 3 line segments. G is that guy, which is the area under the curve from -3 to x. So if x is over here, then it's just the area under the curve. Find g of 3. So A. G of 3 is just the integral from -3 to 3 of f of t dt. So that's 1, 2, 3. So that would be from -3, which is here. So that's going to be this area plus this area minus this area. So let's go ahead and just figure out what those are. This area is 1/2, 3 times 4 is 12. So it'd be 6 plus this area is 2 times 4 is 8. Half of that is 4. And I got to subtract this area down here, which is 1. And that one you really need to make sure how long that is. Don't just eyeball it. So I'm going to figure out what this slope is. This slope is down 4 over 2. So this slope here is actually -2. So that means if I go over 1, I have to go down 2. So that really is 2 down. So this slope is, or this area of this triangle really is -1. So 6 plus 4 is 10, minus 1 is 9. So that's the area, so that's G of 3. B. On what open intervals from -5 to 4, the whole thing, is the graph of G increasing and concave down? Support your answer. Easiest way to do this, I think, is just to look at it this way. For G to be increasing and concave down, that talks about it's increasing when G prime is positive, and it's concave down when G double prime is negative. Well, let's see what those are. G prime of x is f of x, and G double prime of x is f prime of x. So G prime, or G is increasing. I'll write this out. And this is how I do this problem. G is increasing when G prime is positive. So that's when f is positive. In this case, when f is positive. So when is f positive? Well, f is positive on the interval let's see. This is on the interval -5 less than x less than -3, and -3 less than x less than 2, right? That's where f is positive. Okay, now we gotta look at G is concave down. Concave down. When G double prime is negative, so that's when f prime is negative. Since G double prime is equal to f prime right up here. So where is f prime negative? By the graph, f prime is negative. This is when, or this is on the interval, -5 less than x less than -3, and 0 less than x less than 2, right? It's negative on my picture up here and right here. Oh, actually the whole thing. way up to 4. So where is it both? Because we want to know both. So I got to look at these two guys and see what x values are both of those satisfied. So g is both increasing and concave down when negative 5 is less than x is less than negative 3, and when else? Negative 3 is less than x is less than 2, and 0 x is between 0 and 4. So that's when 0 is less than x is less than 2, right? Because x is between 0 and 4 and between negative 3 and 2, so the x's that make both of those true are the x's between 0 and 2. Okay, there you go. And that one is 2 points for that problem. One point for the answer, right here, and 1 point for the reason. Okay. C. H is defined by that. Find h prime of 3. H of x is g of x over 5x. H prime of 3, well, we gotta find h prime of x. That's a quotient rule, so it's the bottom times the derivative of the top. I know some of you have asked, did they ever ask questions from the first semester? I think someone asked, and the answer is, well, they're kind of embedded in here, and here's kind of one that really is. It's embedded here. It's just a simple quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. 25x squared. Don't forget that squared is 5. And then we want h prime of 3. So it'll be 5 times 3. Can I go ahead and just plug it all in here? 5 times 3 is 15 times g prime of 3 minus g of 3 times 5 all over 3 squared is 9 times 25 is 225. Okay, so now I've got to figure out, well, what's g prime of 3? Well, g prime of 3, remember up here, g prime is f. So g prime of 3 is f of 3. F of 3, oops, let me go ahead and, oops, so we said the slope is 2, so right here there's 3, that's down to negative 2. So this is negative 2, right? So that slope's negative, is 2 down. This would be 15 times negative 2 minus g of 3, we did in part A, is 9 times 5 over 225. And if you simplify that, you get negative 1/3. Okay? And D says that P is this function. Oops. I guess I should write it up. P of x is f of x squared minus x. This says find the slope of the line tangent at x equal negative 1. Well, the slope is just the derivative, so let's take the derivative. So p prime of x would be the derivative of this. Well, that's f prime of x squared minus x. This is the chain rule times the derivative of the inside. 2x minus 1. Now we've done this before, chain rule, I'll write it over here, f of g of x. Remember when we said, here's my y, and I said, what's y prime? Oh, chain rule. Outside, think m&m's, g of x, times the derivative of the inside. Don't forget this concept, you'll probably see it. Okay, so p prime, but we want the slope at negative 1, so that's f prime at, if I plug in negative 1, is negative 1 squared is 1, minus a negative 1 is plus 1, times 2 times negative 1 is negative 2 minus 1 is negative 3. So I get f prime at 2 times negative 3. Well, what in the world is f prime? How do you find f prime at 2? Well, let's go up to the graph here. We have the graph of f. And my research not working on here. F prime at 2. Oh, here's the slope. What's the slope at 2? We already determined it's negative 2. So the slope is negative 2 times negative 3 is 6. There you go, and that's worth 3. And you get 2 points for the derivative. That was plus 2 and plus 1 for the answer. Okay, there you go.